In this video, we are going to go over how to find the area of a trapezoid. In a later video, we're going to check out why the formula that we're about to use for the area of a trapezoid works. So let's dive into how to find the area of a trapezoid right now. So we are given a trapezoid right here, and I've given you some notation on that trapezoid. We've got this thing that is read B sub 1, and this is read B sub 2. What that stands for is B2 would mean the second base, and this would be the first base. It doesn't really matter which one's B1 or B2. We use these numbers, which are called subscripts, numbers written below a variable, to recognize that these are two different bases. Okay, now, what makes a trapezoid is that we have one pair of parallel sides. That would be this one and that one. And the height is the part that connects these parallel sides, making a right angle with both of those parallel sides. So the formula that we use for finding the area of a trapezoid is very simply, the area is equal to 1/2 times the height, this thing, times the sum of the two bases, adding B1 and B2 together. Some people learn it this way, which is that you multiply the height by the average of the two bases, which would be adding B1 plus B2 and then dividing by 2. It does not matter which formula you use. I am partial, so I prefer using that first formula there. Partial is kind of a big word for these math videos, so I prefer using that first one. Let's dive into a couple of problems right here and use that formula. So we're given that we have a trapezoid here, and I'm telling you it's a trapezoid. If you didn't know that if it was a trapezoid, you'd have to be given that these are parallel lines. But I'm saying they're trapezoids. So what we have to do is identify the formula we're going to use. It's a trapezoid, so we use that formula, and the parts of this figure that go in the proper places in that formula. So I have that B1, and I'm just going to kind of list it out here because there's so many variables. Base 1 is either 21 or 9. It does not matter which one you use. And I'm laughing a little bit because I'm looking at the numbers thinking that 21 is just barely bigger than that 9. So this figure, not drawn to scale at all. Now from here, we have that B2 is equal to, I'm still laughing about it, 21 centimeters. Right there. So those are the two bases. Again, it doesn't matter which one's B1 or B2. 10 centimeters makes a right angle with both of those bases, and so we know that the 10 centimeters is the height. So now all we have left is to plug these numbers or evaluate these numbers nicely into the area formula. Let's do it and find our area. So we're given that the area is 1/2 the height. Well, the height, as we just saw, is 10 centimeters. So I'm going to write that in parentheses, which signals that we are multiplying by 10, times that quantity of the sum of the two bases, B1 plus B2. So that would be 9 plus 21. Beautiful. Now from here, all we have to do is simplify. So we've actually done the geometry part where we found our area. We just now need to simplify it to find the, well, much nicer number than what this number is. So we multiply from left to right, at least I do, but not before adding up what's inside the parentheses. 9 plus 21 is 30. So we have 1/2 is equal to 10 times 30. And then from here, we're going to simplify from left to right. Half of 10, or 10 divided by 2, is 5. So that's 5 times 30, which is 150. And remember, we're finding square units here, square centimeters. That's it. That's how to find the area of a trapezoid. I've included a second example coming up right now because I thought, why not give you a little bit of a different look to a trapezoid and rock one more problem. So let's do it. So in this problem here, you are given a host of numbers. But again, it is a trapezoid, and so we're looking for our two bases, 5 and 6, as well as the height that is perpendicular to both of them. That's the 3 feet right there. Now, I've given you this slanted amount of 3.2 feet. That's roughly what that number would be, and it's of no consequence, meaning we don't really care about it because it does not make a right angle with the two bases, so we're only going to use what we need for our area formula. So the area, again, is 1/2. I'd start out by writing it out. The height times the base added to the other base, B1 plus B2. Okay, so I'm going to identify these and I'm going to show you how you can do this a little more efficiently. You can certainly write out everything and list it all out and plug it in. I'm going to plug in all the numbers as we go. So my area is equal to 1/2. The height is 3 feet. Okay, sweet. So I plug that into the formula, times the sum of the two bases. B1, let's let that be 5. It doesn't matter which one is B1, as long as B2 is the other base, which is 6 feet, plus 6. Sweet. So now all that we have left to do, like we did in the last problem, is simplify away. 5 plus 6 is equal to 11, using the order of operations here, like we use it so frequently. And now here's the interesting piece. We have 1/2 times 3 times 11. Nothing will divide nicely here. That's okay. No problem. What I would do is I'm going to actually multiply the 3 and 11 first, which is totally fine. Multiplication is commutative. And then I will take half of that. So it's 1/2 of 33, which you can either leave as 33 halves, or you can write as a decimal, which is 16.5. And of course, that's going to be square feet. Feet squared. And that's it, peeps. That's all we've got. A couple of trapezoid problems, how to use the area formula for those trapezoids, and it's all about identifying the proper pieces and plugging those proper pieces into the parts that are represented in the area of a trapezoid formula. Go rock some problems.